Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2. So we want to present for our topic which is Process Control Analysis and Improvement of a Hybrid Shear Enhanced Flotation Separation SEFS and Dissolved Air Flotation DAF system for winery wastewater treatment.
Hello, hi, Assalamualaikum. My name is Siti Maisura binti Maududi. So here I will present about the backgrounds of study. The winery industry generates a significant amount of wastewater during activities such as grape crushing, fermentation, cleaning and bottling. This wastewater is characterized by high organic content, high suspended solid and wide fluctuation in pH and flow rate. If not properly treated, winery wastewater can cause serious environmental problems including oxygen depletion in water bodies and damage to aquatic ecosystem. Conventional treatment methods such as sedimentation and conventional dissolved air fluctuation often struggle to handle the high strength and highly variable nature of winery wastewater. To overcome this limitation, advanced separation technologies such as shear enhanced flotation separation, when combined with dissolved air flotation, have been introduced to improve solid liquid separation efficiency. However, the performance of the shears enhanced flotation separations and dissolved air flotation system is highly depends on effective process control, particularly in managing flow rate, pressure, pH, and chemical dosing under fluctuation influence condition. Therefore, this project focuses on analyzing the existing control system, identifying its limitation and proposing improved control strategies to enhance treatment efficiency, process stability, and operational safety. In the following section, we will discuss the system background, process description, control analysis, and the proposed improvement of the shear enhanced flotation separations dissolved air flotation wastewater treatment system. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif. So I will present about literature review. For the first one, winery wastewater characteristic. Winery wastewater has a complex and changing composition. It has a lot of organic matter, small particle and nutrient like hydrogen and also phosphorus. The flow and pollution level can change over time, so normal treat method may not work well. If the water is released without treatment, it can cause environmental problem like too much algae in the river and lake. Because of this, we need a treatment method that use a mix of chemical, physical and mechanical process. So for coagulation and flocculation process, coagulation and flocculation is a main treatment method for winery wastewater. In this process, chemical coagulants are added to remove the charge from small particles. Gentle mixing make the particles stick together, and from bigger clump is called flock. Flock are easier to remove than single particles. This process works well to remove small organic particles that cannot be removed by physical method alone. The success of this process depends on things like the type of chemical used, the dose, the pH of water and the mixing, and also the time the water is treated. So we go to the next part, which is dissolved air flotation, which is DAF. DAF is a method to separate solid from water using tiny bubbles. A is dissolved in the water at high pressure and released at normal pressure to make tiny bubbles. Thus, a bubble attached to particles and make them float to the surface. DAF work well to remove light particles, small solid and organic matter from winery wastewater. The efficiency of DAF depends on factors like the size of bubbles, the water pressure, and the flow of water in the tank. So we go to the next part, shear and change flotation separation, which is we call SEFS. SEFS is advanced version of DAF. It adds strong mixing shear before flotation to help small particles join together to make bigger flow. This bigger flow attach better bubbles and flow more easier. Study how that SEFS combined with DAF remove more COD, turbidity, and suspended solid than DAF alone. This method is very suitable for winery wastewater. that is complex and has changing condition.
I will explain the process description and the piping and instrumentation diagram or PID of self-duct system used for winery wastewater treatment. It explains how the system operates step by step, the major unit operation involved, and the instrumentation and control element that support the process. The self-duct system is a hybrid flotation-based wastewater treatment process designed to treat high-strength winery wastewater. Winery wastewater is challenging because it contains high organic content, suspended solid, and high fluctuation pH value. This system combines chemical coagulation, flocculation, hydrodynamic shear mixing, and dissolved air flotation to enhance solid-liquid separation efficiency. So the purpose of self-duct system is to integrate self with duct is to overcome the limitation of conventional dissolved air flotation system. In traditional duct, fine particle and colloid may not attach effectively to air bubbles. By introducing hydrodynamic shear, particle colloids are increased, floc becomes stronger, and bubble particle attachment is improved. This results in more stable and efficient flotation, especially under fluctuating effluent conditions. For overall process flow of the self-duct system, begin with screening, where large solids such as grape skin, seeds, and other debris are removed to protect downstream equipment. The screened wastewater is then stored in the intermediate bulk container, which act as feed tanks and provide initially mixings. And then the wastewater undergoes pH adjustment since winery wastewater is usually acidic. Lime slurry is added to raise the pH to around 9. This creates optimal condition for effective coagulation and flocculation. After pH conditioning, a polymer aluminum-based coagulant is added to neutralize the negative surface charges of colloidal particles, initiating particle destabilization. This is followed by the addition of flocculant during the flocculation stage, where gentle mixings allow particles to form larger and stronger flocks. The piping and instrumentation diagram or PNID provide a detailed representation of the self-duct system, showing the piping layout, major equipment, valve, pump, and instrumentation used for operation and monitoring. Unlike the process flow diagram, the PNID focuses on control, safety, and operational aspect of the system. From the PNID, key components such as flow indicator, pressure gauge, control valve, chemical closing pump, and the hydrodynamic shear mixing can be identified. These instruments are installed at critical points, particularly along the influent and recycle line, to regulate flow and pressure and ensure stable operation. The major unit operation in this system include coagulation flocculation in the IBC tank, hydrodynamic shear mixing, dissolved air flotation, and recycle pressurization. Each unit plays an important role in enhancing particle destabilization and separation efficiency. Overall, the system relies on basic instrumentation and manual control, making it semi-automated and highly dependent on operator experience. These limitations highlight the need for improved process control, which will be discussed in the next chapter.
Hi, Assalamualaikum. My name is Muhammad Rizwan Arif. My matrix number is CN240109. So I'm going to present about chapter 4, which is the existing process control system. So in this slide, it shows the overall existing process control system of the SEFS DFF unit. Based on the PNID, the system operates using manual and semi-automatic control. As you can see, the influent flow, recycle flow, pressure, chemical dosing, and shear intensity are all monitored using a basic instrument such as the flow meters and the pressure gauge. However, adjustments are carried out manually using valve and pump settings. There are no closed-loop PID control, so the system relies heavily on operator experience, which can cause slow response when disturbance occur. So in this slide, we will talk about the control objective of the system. So the main control objective of the system is to ensure a stable and efficient treatment of winery wastewater despite a large fluctuation in the flow rate, pH, and organic load, and also the suspended solids. So the key objective include maintaining stable influent and recycle flow, controlling pH and chemical dosing, and also ensure sufficient recycle pressure for the microbubble generation. And this objective directly affect the float formation, bubble attachment, and flotation efficiency. And currently, most of these objectives are achieved through manual operation, which limit fast corrective action. So next, we are going through the identification of process variable. So in order to analyze the effectiveness of the existing control system, the process variables are first to be identified. So based on the PNID and process flow description, the variables are classified into three main categories, which is control variables, manipulated variables, and disturbance variables. So understanding these variables are important because they can interact with each other and also determine the overall stability and performance of the system. So the first process variable that we're going through is the control variable. Control variables are the key parameters that need to be maintained within the acceptable limits to ensure effectiveness of the treatment. So these include effluent flow rate, recycle line pressure, wastewater pH, effluent turbidity, suspended solids concentration, and also liquid level in the DFF tank for this process. So although these variables are monitored using flow meters, pressure gauge, and also the sampling point, they are not automatically controlled. As a result, deviation may occur during sudden changes in the effluent condition. So next is the manipulated variable. So manipulated variables are the parameters that operators adjust to influence the control variables. So in the system, the manipulated variables that are being watched is the valve positions, chemical dosing rates for lime, coagulant and flocculant, recycle flow rates, and hydrodynamic shear mixer speed. So all of these adjustments are done manually based on operator judgment and also experience. This increases workload and can lead to inconsistent system performance during a high variability conditions. So the last process variable that we're going through is the disturbance variable. So for disturbance variables, there are factors that affect the system but cannot be controlled directly. So for this winery wastewater, the major disturbance include is the fluctuating effluent flow rate, the rapid pH changes due to the fermentation and CIP operation, and variations in organic load and suspended solids, and also temperature changes. So this disturbance make manual control a little bit challenging and often cause delays in the corrective actions, and also it will lead to the unstable treatment performance. So this is the last part of this chapter 4, which is the existing control loops and limitation. So to briefly present, the current control system mainly uses the manual and open loop control. So the flow and pressure are controlled by manually adjusting the valve. Chemical dosing is based on the operator's experience, and the shear mixer operates without any feedback. So moving on to the limitation, the main limitation of the system are the slow responses and high dependence on operator, and also the risk of dosing error, and last is the lack of safety automation. So these weaknesses clearly shows that why we need to improve the PID based control system. So that's all from me. The improved PID based control system will be discussed in the next slide.
Thank you, Rizwan. Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Aina Najwa bint Roslan. So I will continue present for purpose control system improvement. Okay, for the first improvement, we implement PID control for flow rate and system pressure. So this control system will automatically regulate the influence flow and recycle pressure in the SEFS duct unit by maintaining the stable hydraulic condition. So the system will ensure the constant system shear mixing and microbubble generation. As a result, bubble particle wheel attachment becomes more effective and flotation performance is significantly improved even when the wastewater flow fluctuates. Okay, next for the second improvement, we have PID control chemical dosing is introduced using online pH and turbidity monitoring. So the system continuously measures the wastewater pH and turbidity and automatically adjusts the coagulant and flocculant dosing rate. So this ensures the optimal coagulation and flocculation at all times. So as a result, chemical over or under-dressing is reduced. So the sludge formation becomes more stable and influent quality is more consistency. Okay, lastly, for the third improvement, PID based level control is implemented together with the safety interlock and a bypass system. So the level will control the maintained safe liquid levels in the SEFS stuff and treated water tanks. So high and low level interlock protect the pumps from the overflow and dry running. So in addition, the bypass system allows the continuous and flexible operation during maintenance or abnormal condition. So it will improve the overall system safety and reliability. Okay, next, this slide shows the improvement PID with an integrated PID control system for the SEFS stuff wastewater treatment process. So, the main purpose of implementing PID control is to automatically maintain the stable operating conditions despite the highly variable nature of winery wastewater. That's all from me. I will pass to the next presenter.
In conclusion, this project focuses on analyzing and improving the process control of a high-bridges enhanced flotation, spiration and dissolved air flotation system for winery wastewater treatment. Winery wastewater presents significant challenge due to its high organic load, suspended solid and fluctuation operating condition, which require an efficient and stable treatment system. Through this study, we identified key limitations in the existing control strategy, particularly in terms of flow rate regulation, pressure control, pH stability, and chemical dosing. This limitation can affect spiration efficiency and overall process performance. Therefore, improved control strategies were proposed to enhance stability, operational safety, and treatment efficiency under varying influent conditions. Overall, the proposed control improvements are expected to support more reliable wastewater treatment. That's all from me. Thank you.